Hello, this is Hyunjun Kim from Finance Q Institute, and I'm the undergraduate student at Sunshi University, South Korea. And this conference is this is English version of our conference in Finance Q, which is undergraduate community of quantitative finance. And So, for the goal of this conference is to introduce and um, discuss about complex economics and finance. And the first conference, which is this one, is about synthetic market simulations and its discussion. So a synthetic market simulation and its discussion, the title itself is a little bit deceptive because the focus is not on synthetic market but on the market simulations. Um, and the main theme of discussion is about whether or not the market is actually efficient or not. And the comparison about uh, competitive equilibrium and the complex models. The models like ABM or something like that. So it's a little bit similar to those models. So let's compare. So comparing those two is the main topic of this conference. Okay. So we need to define some terms using the conference. Most of them are conventionally correct, but some of them are defined by myself. So the terms will be a little bit different. So I have to clarify those things before I move on. So the firstly, revenue. It not only means the surplus money that is earned by the supplier by selling the products at the price exceeding the production cost. So there is uh, there is money that is left on the pocket. Uh, but it also means the money that the consumer saved by buying the products which price is lower than its maximum budget. So what that means is that if the consumer is willing to pay $50 but buys a product at $40, then the revenue of the consumer is $10. So usually we don't call this a revenue, but in this conference, in this context, I will use revenue as same as I use revenue to mean also this. And the efficient market is really a broad term and also widely used. But it's simple. So we talk about revenue just before this. So the efficient market is a market which tends to maximize the revenue of every people inside the market, or who's trying to trade. And the revenue cannot be minus because uh, nobody will trade if it is cost something to them. So for example, a supplier will not sell a product, let's say Apple, at $1 if the production cost is $1.5. So it loses 50 cents if he or she sells. So that is a little bit not rational, which I'm going to come up later on these definitions. And the agent-based model, or short for which is shortened to ABM, is a mathematical models which model the phenomenon by groups of what we call agents, or maybe we can call it individuals. It's a broad, really vague definitions right now, but well, I'm not going really deep into this right now because it's not main focus. But I'll use this term to describe the model is that is used in this conference to uh, use in this conference. Yes. And economically, rational individual is also a well-known concept, which is individual that acts to maximize its profit within the same risk or cost, or minimize the risk or cost within the same profit. Uh, we can call it profit, or we can call it profit, revenue, or a return, any kind of things. I will use it interchangeably, although there is a slight difference between the words meanings. It's a nuance, it's a little bit different. However, so some members might ask, some finance Q members might ask, well, why don't you say just maximize profit and minimize the risk or cost? Well, that's a slippery slope, I think, because if the profit and the risk or cost are interconnected, let's say a portfolio, it is impossible to maximize profit and also minimize the risk. It's a different term in mathematically different situations. And sometimes it is impossible to maximize and minimize, or we can compromise to just compromise with some kind of metric to even out the maximization and minimizations, or there could be some mathematical method to do that, but that really comes into think that evokes the interference of the idea of subjective rational, because that has to that method has to define how much maximization we need and how minimization we need, or something like that. That's a little bit of slippery slope. So I'll just say that the rational individual is defined like this. I think this is a more widely used term in economics. So, yep. So the main topic, are markets efficient? So uh, there is a theory about the competitive equilibrium. So, well, started from Adam Smith, and it goes on until today. Um, it still remains until today, and that concept suggests that even when the individuals do not um, act in the certain seamless way, the markets move towards the most efficient form. And the efficient, as I told you earlier, it means that to maximize everyone's revenue, including the people who is um, including the people who's trading or not. So it's a really strange idea, because if we trade the goods, it seems like we're gaining revenue, right? Because we bought. If the trade is made anyway, it seems like when many people, if the people, uh, the more people trade, the more revenue will generate. The market will generate, but it's not true, as is proven. And you can see that the underneath the text there is a graph, a really famous graph of demand and supply, and the intersection between those two graphs is the place where competitive equilibrium formed. So that exact place is where the price of the the product will be formed. The price of the product will be formed, and most people will trade in that thing. This is not really technically true. I mean, it's not technically true, um, because in the real life there is some monopolies or many kinds of situations. But if you're talking about the ideal competitive behavior, we can expect to have equilibrium. Um, yeah, and this idea has to assume that every individuals have every information about the market, and every individual is completely rational. The rational I already said in the first slide, in the previous slide, that how it's defined, about how it's defined. So this is it. This is a really long. This is the really ancient theory. We can say we can say this is ancient theory because it's started by Adam Smith, which is really long time ago. Which is long time ago, and it still remains today. Well, we changed the form into uh, by John Nash or many people's, but the idea of equilibrium is really a dominant idea in economics. We can't say it will actually the term ideas is going to change, and the change of idea will be presented. Those changes will be presented in this conference, but I will not say right now. But this is a really important idea of economics, I will dare say, as I say. Okay, so the doubt about the premise. Uh, of course, the premise means the premise of the or premise or the assumptions of the competitive equilibrium. So, is it possible for an individual to get every information about the market? Is it possible? Well, there are some kind of things like um, we an auction or some sort of special markets. There are people who tells everybody who wants to sell it, buy it at some price, and somebody will say another more higher prices. But this is really tricky job, and actually there are some behavioral finance behind those things. It is possible that it is interfered by irrational things. So the two assumptions are generally not true. But if you focus on just one thing, set aside the irrational or irrational idea. If we assume that it is rational, is it possible? Is the equilibrium exist even when every people doesn't have the full information about the market? So there is a quote. It's not the actual quote, but it's a similar thing. I can find the original English text, but I translated from Korean. So Friedrich Hayek is a famous economist. Once said that the solution of the problem could be proven only by giving a person every single data or information in the market. We have to, I'm sorry. So if the solution of the problem could be proven only if and only if a person is given every single information in the markets. The problem is actually the solution of the problem is impossible to prove. Rather than using these unrealistic assumptions, it is more plausible to use partial information for give out partial information to the individuals and see um, what that shows. So there's another doubt about this approach. Is there's a doubt about this approach because um, is it possible to make really is it possible to make a complex uh, price complex trading phenomenon just by using computer, just by generating the simulation over and over again? Is it going to move like a real market? So we it's not certain about that, but we can assume that is possible because there are already been some studies about these which is called the cellular automata. So this one proves that even when the computer is given a local rule between neighboring individuals and some initial conditions, the result of the computation will include some complex and chaotic behaviors. What do you mean by chaotic? Well, I make a bracket and say nonlinear, but the nonlinear doesn't mean chaotic is an important theme, important concept, but that's not important right now. But the chaotic is something like this. So if you look at the right side of the slide, there's two pictures. The upper picture is upper picture and the down picture is had the same rule about the cells, which is a little bit of a square dot in this plot. So a dot is defined. Dot will be white or black, um, according to the cells above the cell above this cell. So if the cell above the cell there is three cells, neighboring cells, which is upper right, upper left, and upper middle. So those three cells define what the what will happen if we uh, what will those define what color will the next cell will be, next layer of the cell will be. So this is a little bit of really, um, really complex computational idea. So I'm not going to go deep into this because it's not really important right now. But as you can see, these two pictures has the same rule but have a different initial conditions. So initial condition is the line right in the very top line of squares, and the upper ones is randomly generated, and the lower part is um, all the right and left left cells being white and the black little bit of dot in the middle. So what that makes is a really different kind of form. The upper part, the random initial conditions, shows a really chaotic and really complex form of uh, the patterns. It certainly looks like some artwork in some sense, or some naturally occurring patterns uh, in maybe in a animal's body, or in maybe in the plants. But the lower part is really looks synthetic. Actually, this is what we call in mathematics a fractal. A fractal, which means is the if you scale the image of some if you scale up the object, it looks similar to the object before it's scaled. So you can see it's lots of triangles fitting inside the bigger triangle, and so on and so on. And Yes, and this is shows that even if there is a different condition, wait a second, sorry. So if the different initial condition is given, the difference between two different initial conditions will cause really different kind of results. So this is we usually say is talking about nonlinear, and it is sometimes related to chaotic behaviors. This actually this time is not actually it's proof that it's chaotic because the initial conditions are quite different with each other. But if you check the program is generated and change the initial condition a little bit, you can see that the results change dramatically. Anyway, this implies that the complex process of market trade, which we discussed earlier about the individuals trading randomly with partial information, which is actually the local rule in this case. And if we given initial conditions, this will partially could be simulated by similar models, like cellular automata. But the cellular automata is actually a two-dimensional graphic version of this model. So we need a more sophisticated one for simulating this kind of things. And there is actually a study on this kind of things. It's called Bazaar economics, studied by John Miller. And this trade model is this conference replicates this study, but in a different way. So there is slightly different things. There is a different initial conditions. If as you can see in the right picture, there is in the right figure we can see there is two histogram of supply and demand, and they're symmetric. They're mathematically symmetric, and there is a green line which indicates the place where the competitive equilibrium expects the price will form, and there is 94 55 9455 or 9,455 suppliers and consumers, and each trade process consists of random match of suppliers and consumers which didn't trade and only trade in mean price if the supplier's price is lower than the consumer's price. So in this case, the price doesn't really mean the supplier's wanted price. It's the production cost, we have to say. But the suppliers tend to sell it over or as same as the production cost. So this is fairly made rule. In the trades, the single simulation iterates 500 times the trade. So if the trade is made, the leftover suppliers and consumers try to trade, randomly match and try to trade in the next iterate, and those iterates loops around and around until 500 times. So there's a possibility that not everyone will trade. There's a possibility that everyone there's a possibility that not everyone will trade. There is a possibility, but we have to say there's um, we are assuming that the 500 iterates are enough. And if you look at the simulation results, it seems like the 500 is just enough. So the complex simulation of the synthetic market is this is a single simulation results this time. So the price mean is 15.5058, which is really close to the competitive equilibrium expects it to be. And the price standard deviation is 3.8413, which is quite large. So there is lots of trades that is made, which is not really efficient, according to competitive equilibrium. So trade volume is 1,808, and you can see that it is way over the value which competitive equilibrium suggests, which means that the trade which is made between these peoples with lower or higher cost, higher cost than the competitive equilibrium suggests, is quite inefficient. So the complex simulation of synthetic markets, this is a multiple simulation results. Sorry, I'm repeating the top title. I'm a little bit the surrounding is a little bit distracting, so I'll apologize for that. So this one is a 100 simulation iteration, which each simulation iterate 500 trades. So each time, most time, and maybe almost all of the time, it seems, the revenue, total revenue of the market is way lower than the competitive equilibrium suggests. So there is a real inefficiency in this market, in this synthetic market. So few questions. Is the market efficient? The simulated market efficient? It tends to, but not perfectly, which means that the price distribution is quite looking bell-shaped, and is bell-shaped and centered in the middle. So it means that there is a tendency of trying to be in the optimal price, but the standard deviation is quite big. So this is not really ideal efficiency. And if you see the graph here, you can see that the graph doesn't looks like the synthetic market is not really efficient in any way. So that's answer the second question: is the real market give everyone highest revenue? So synthetic markets is a really extreme part of this extreme part of the markets. The people are only able to guess. The people are only getting really small amount of data, or really small amount of information about the markets. Each time they trade, they only get um, one people's one person's price, production cost, or suggesting maximum budget. So those two things are different. So most markets tends to I'm sorry, a little bit distracting on the outside, so I will not let this happen in the second conference. Anyway, so the market tends to is trying to be efficient, but in the this shows that the efficiency and the um, information, the university uh, and the universal information is really interconnected. Um, so is it appropriate to interpret the mean value of the price as the market price? So, in my opinion, uh, this is interpreted, it should be interpreted as a tendency. So, um, so as a model, as if there is a linear model, or is there any kinds of model is trying to model some realistic part, and if you're trying to model this synthetic market, we can regard the any trade outside of the optimal price. We can say that those things are noises. Those are noises, and those noises are not relevant to the real true optimal price. So we can say, is it possible to say there is a tendency? However, the standard deviation is too high for generalizations. So it's not possible to assume that everyone is trading in the optimal price. It's too large for that. And what this indicates? So this shows that the market tendency of the equilibrium quite exist in this time, in this certain type of market. But the lack of information causes inefficiency as well. I think the really good way to prove this is to make the people to choose between two or more suppliers and two or more consumers, and they try to match the most. They're trying to trade in the most efficient way. However, this is a little bit of difficulty in the mathematical part, and also in some part, because you know that people's if we give a two consumer, if one supplier gets two customer or consumers, and they come to you and say, your price is reasonable, I'm going to buy it, but you have to choose between those two price range. So one of the way is to choose the most expensive part, but most expensive price, right? The more expensive price. So this is rational. And this computations causes more. That computation needs more times and space in computer scientific in the computer science in the concept of computer science, time and space. And also, if we include more and more suppliers and consumers, it became more difficult to solve. But I think it is worth the shot if it proves that the lack of information causes inefficiency, which is certainly being studied a long time in economics, and I think that's certainly right. But anyway, this shows that the market tends to be efficient, but it is cannot because of the uh, lacking informations. Thank you for listening, and if you want to contact me or the Finance Q, you can use my personal email, which is shown in the text, or you can visit our website. There's two websites right now. Um, Maybe the foreigners doesn't know about Naver, and Naver is internet sites just like Google, but for Koreans. And there is a service called Cafe, which is internet community site, and we have a community site on there, and some of the contents are available for everyone in the internet, but they're in Korean, so I don't really suggest to look at because it's impossible to, maybe most of you will not understand it correctly. And the FinanceQ website and Wix.com, there is a site, but is preparing right now, and the English descriptions are in process. So maybe you cannot get any information from these two sites, but I cited them anyway if you're interested, or if you're a Korean speaker and you know how to read them. If you want to give me any comments or any types of suggestions, or any kinds of revision, feel free to email me at this address.